In our last lesson, we learned how to figure out how much energy and charge are stored on a battery so we don't get overcharged for our batteries that are no good. So we learned how to deal with watt hours and amp hours. We learned that some companies are going to try and trick us by putting in milliamp hours so it sounds larger. We learned how to take the ratings of the battery and figure out what we could do with the battery. Whether it is adding heat energy, potential energy, kinetic energy, it doesn't matter. Today I'd like to talk to you about combining batteries together. So we already learned that the voltage of the battery is determined by the chemical reactions. We learned that this is 1.5 volts and this is 1.5 volts. But what if we need a greater voltage than we can get from our chemicals? What we want to do in that case is we want to combine batteries together to either give us a greater voltage or to give us a longer life. I don't know if you guys ever use these because now we have phones that will act as flashlights for us. But if you ever use the flashlight, it usually takes multiple batteries and you have to put the batteries in a certain way. You're combining them together in such a way that you're going to get more voltage out of your battery pack than you would from the single battery. But you have to do it right. So there's two ways you can hook your batteries up. This bottom way is called parallel. So draw this out. And this is called a parallel connection. This is called a series connection. In both cases, the black wire is going to represent the negative that we hook up to our light bulb or other object. And the red wire will be the positive that we're going to hook up to our light bulb or other object. So I'd like to know what is it we're going to get out of each of these different combinations and how are they actually connected. Let's start with the series. So here's our negative. And here's the positive end of our first battery. You'll notice a piece of metal connects the positive of one battery to the negative of the other. And this trend continues. Positive touches negative, positive touches negative, and the final positive is where we pull our power out of. The original negative is where we're going to pull our power out from the other side. So we hook up to the first negative and the last positive. They're connected positive to negative, and that trend continues. So when you're putting your batteries in a flashlight, like this one, you drop it in, positive side up. The next one, you also want positive side up, so that positive touches negative. This is a series connection. And what you're going to get is 1.5 volts from each battery, and they are going to add together to give us a total of 6 volts. So in a series connection, your voltage increases with each new battery that you add. In a parallel connection, they do not increase. We hook the positive of the first battery to the positive of the second, the third, and the fourth. We join all the positive terminals together, and we join all the negative terminals together. We then pull our electricity from any of the negatives, since they're all joined together, and any of the positives, since they're all joined together. And what we would get out of this is a total of 1.5 volts. Why would we do this? Why would we connect batteries together and not increase our voltage? Because this connection would increase the life of the battery. If one of these batteries was dead, we could still get the 1.5 volts from the other three. This would last, if all the batteries started out good, 4 times longer than a single battery. In this connection, if one of our batteries was bad and we could not flow through that battery, the whole thing might stop working. Okay? We wouldn't for sure be getting our 6 volts, and we might not be getting anywhere close to even 4.5 volts. One bad battery can ruin the bunch. Okay? So if you need more voltage, you hook up in series. If you need more life, you hook them up in parallel. So again, here is the flashlight. You can see this is the negative end, this is the positive end, and we join positive of the first to the negative of the second. This would give us 3 volts from this combination of batteries. Okay, so you can see I have a single battery. This is a 6-volt battery, and you can see it reading 6 volts. You can see I now hooked 2 of them up, and I'm now reading a little more than 10 volts, almost 12. You'll notice again I'm pulling from the negative of the first battery. I'm hooking the positive of the first battery to the negative of the second, and I'm pulling out of the positive of the last battery. This is a series connection, and I'm getting 12 volts. You can see I could keep doing this and keep getting more and more voltage. So let's take a look. 1 battery, and you should be reading on this top scale, so this would be 50 volts if I ever got to there. 6 volts. You can see twice as much, we're now talking 12 volts. 18 volts, and so on and so on. I can keep adding and adding batteries and get my voltage as high as I possibly want. Okay, each new battery gives us more volts. This person took it to the extreme. They took a bunch of 9-volt batteries, they connected them up in series until they had a total of 244 batteries. Times 9, we're talking over 2,000 volts. They then take the 2 ends and connected them, which is a really bad idea. And you can see the tremendous spark they were able to produce because they had over 2,000 volts. So again, series, more voltage, parallel, more life. Series, positive to negative. Parallel, positive to positive to positive. Okay, here we go again. This is our parallel connection. Positive to positive, negative to negative, and then we pull our electricity out of either of the 2 batteries as we're doing here. And you can see we're getting about 6 volts. With your car battery, if one car battery is dead, you can jump another car battery by hooking them up in parallel. Not in series, parallel. Positive to positive, negative to negative.